the questions I sent to you in relation to the circle were basically composed of most of what you need to do. There's one other type of question I want to do with you, and that's building up 3 equations in 3 variables, but I think I gave you enough of those in the previous question. I didn't really include them here, but if you feel I need to include them, I will do one maybe later on, send it to you on Saturday. But I want to run through the ones I gave you today just to make sure that your procedures are fine, or if you get stuck in anything, at least you have a solution to fall back on. So let's take question 1 here. The point minus 2k is on the circle x minus 2 to be squared plus y minus 3 to be squared equals 65. Find the 2 possible values of k where k is an element of z. And I'm just going to make that bigger, that screen. It's better. Okay, where k is an element of z. Now, there's a couple of things I want you to notice here. First of all, I want you to notice that the point is on the circle. And what that means is that when the point is put into the equation of the circle, the left-hand side of the equation will be equal to the right-hand side. Okay, that's because the point is on the circumference. Okay, that's the first thing. The second thing is 2 possible values of k. So you prepare yourself for a quadratic equation in k. And lastly, the values I get, k, they must be elements of what we call the integers, positive or negative whole numbers. So there's quite an amount of information given to you here to make sure that you know your answers are correct. So let's do what we said we were going to do. Let's put minus 2k into the equation x minus 2 to be squared plus y minus 3 to be squared is equal to 65. Now if that's the case, if that point is on that, then we're expecting the left hand side of this equation here to be the same as the right hand side. So minus 2 is minus 4 squared is 16. K minus 3, there's nothing much we can do there. We don't know the value of k, so just put in as k minus 3 to be squared equals 65. Okay, now we've got a binomial here that we want to square. So this binomial squared, you should know how to do these off the top of your head. Square the first one, k squared. Multiply the 2 parts of the binomial together, minus 3k. Double the result, minus 6k. And the last one then is the last term squared, which is plus 9, and that's equal to 65. So now you're going to make your quadratic equation. K squared minus 6k. Well, 16 and 9 is 25. Bring the 65 over as minus 65. That's going to leave you with minus 40 is equal to 0. And because we were told to get 2 possible values of k, a quadratic in k is just what we need. So we know we're heading on the right path in this question. Always check for factors before you resort back to the minus b formula. All right? K squared is k by k. And I want factors of 40 with a difference of 6 between them. Well, 4 tens are 40, and there's a difference of 6 between those. I want the difference to be minus 6. So minus 10 plus 4. And that gives me k is equal to 4, or k is equal to 10. Minus 4 that should be, because take it over the equal sign. So k is equal to minus 4, or k is equal to 10. Okay, that's the first part done. Second part, the circle S is in the first quadrant, and it touches both the x-axis and the y-axis. The line T, which is 3x minus 4y plus 6 is equal to 0, is a tangent to S as shown. Find the equation of S. A lot in there, and a lot in there that you might miss if you haven't picked up the fundamental basics about how axes are tangents to circles and what they reveal about the equation of a circle. First of all, if both the x and the y-axis are tangents, let's just take a look at that. And I told you this already. X-axis is a tangent to the circle. What does that mean? That means C is equal to G squared. That's an identity, and I went through that with you in a previous class. If the y-axis is a tangent, what does that mean? That means that C is equal to F squared. Okay, and again, an identity. Now, just in case you're wondering, how did he get that? Well, first of all, if this is a tangent, just keep this in mind. Here's a tangent there, and this is a tangent here, okay? And this is the center of the circle. Now, the center of the circle, if we don't know its value, is taken from the third of the equations of a circle, which is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, where the center is minus g minus f. Let's just write that down. Minus g minus f, okay? That means that it is minus g units out, so that's minus g, and it is minus f units upwards. That's how you get to minus g minus f. You run out minus g and you run up minus f. Now it sounds counterintuitive that I'm talking about minus g minus f, but take it that that is the center from the third equation. It's minus g minus f. Now take a look at this. If the radius is minus g and minus f, well then when the x-axis and the y-axis are tangents, you can set both of those equal to the radius formula. So for example, minus g, I'm just going to do one of these because you can do one yourselves in a moment. Minus g is equal to the square root of g squared plus f squared minus c. What does that mean? That means that minus g, the radius, is equal to the radius formula. G squared plus f squared minus c. So when I square both sides, I get g squared equals g squared plus f squared minus c. Both of those cancel, bring the minus c over to the left hand side, and c is equal to f squared. Okay? So that's when the y-axis is a tangent. Now the same thing occurs for the x-axis being a tangent, but again, I've gone through that with you already, so please keep in mind that that is an identity that you have to know. So just let me take that off now, because I've just gone through that as a point of revision. So let me, sorry about this now. Okay, so let's take that off, because that's only revision. Okay. We on red. We are. Good. So they're the two identities. Now, what do I get from both of these? Well, if c is equal to g squared and c is equal to f squared, well then g squared must be equal to f squared. And if I get the square root of both sides, g is equal to f. And that's an extremely important identity. Because if g is equal to f, then that fundamentally changes the nature of the coordinates of my center from minus g minus f to minus g minus g. Because don't forget, if f is equal to g, they can be interchanged. So let me just take off this f here, and I'm going to change that for g. Okay, I'm just going to take these out of the way as well, so we don't need them anymore. And this one here. Okay, so there's minus g minus g. So that's the center, all right? Which means now that really g is going to be my focus. What I also know, if this is minus g, what does it mean? It means that it's minus g units out and minus g units up. Now you can't argue with that. What can I take from that? From that I can take that the radius is equal to minus g. All right, so that's what I get from this situation here. G is equal to f and r is equal to minus g. Now what have I been asked to do? The line t is a tangent as shown. So if t is a tangent, tangents are always used with circles in order to draw your attention to the perpendicular radius that is associated with it. So here we have a perpendicular radius running this way. Okay. We know that that's another radius, so that again is minus g. So now what do I know? I know that the center minus g is minus g units away from this line here, which is 3x minus 4y plus 6 is equal to 0. Listen to that again. The center minus g is minus g units away from the line, the tangent, 3x minus 4y plus 6 is equal to 0. Everything is written in terms of g. So that means we're going to fall back on the perpendicular distance formula. Now my advice to you would be always write down what the formula is first before you use it. You'll always get marks for a bare formula, but you won't get marks for a formula that's filled in wrong. Okay, so be careful. A squared plus b squared. Now, what do we know? What is the perpendicular distance? Well, the perpendicular distance is the radius. The radius is minus g, so let's stick that in there. Equals ax1. So we take the first part of the point and put it in for x. What's that going to give me? Minus 3g. Then we take the second part of this coordinate and put it in for y. That's minus 4 by minus g, which is plus 4g. And then the last part is the final constant, plus 6. And that's all over a squared plus b squared, which is the square root of 9 plus 16. Now what does that give me? Minus g equals, let's tidy up the right hand side, minus 3g plus 4g is g, plus 6 over 9 and 16 is 25, square root of 25 is 5. Now clear the fraction. Minus 5g equals g plus 6. Do you notice that? We're now working in g, so we can solve this. minus 6g is equal to 6, which means that g is equal to minus 1. And because there's no f, we don't need f, for the very simple reason we already said f and g are exactly the same thing. What does that tell me? Well, if g is minus 1, then the centre, from what I read up there, must be minus g, which becomes 1, 1. You just change the signs when you put them back in. And the radius is also minus g, which is minus 1, which is plus 1. And now that I know that the centre is 1, 1, and the radius is 1, I use the second of my circle equations, which is x minus h to be squared plus y minus k to be squared equals r squared. And I use that when I know what the centre is numerically and it is not on 0, 0. Okay, so all I've got to do is put 1 in for h, 1 in for k, and 1 in for r. X minus 1 to be squared plus y minus 1 to be squared equals 1 squared, which is 1. And that's the equation of your circle. Okay. Next question. Question 2. The line M, 2x plus 3y plus 1 equals 0, is parallel to the line N, which is 2x plus 3y plus minus 51 equals 0. Verify A is on M. Now, A is on M. What does that mean? That means when you put A into M, the left-hand side, same before, left-hand side will be equal to the right-hand side. So in other words, when I put that point into this equation here, both sides of the equation should be the same. Well, let's do that. Minus 2 times 2 is minus 4. 1 times 3 is 3. Plus 1 should be equal to 0. You can't argue with that. Minus 4 plus 3 plus 1, 0 equals 0. The point is on the line. Okay? Now, they're drawing your attention to that point for a reason. That's not just given to you to show that you're good at algebra or good at putting points into lines. That's a hint as to what to do next. So let's just take a look and see what we're dealing with. Find the coordinates of B. B is there, let me highlight it. So find the coordinates of B, the point on the line N, which is closest to A as shown below. Okay, so now B, I want to get the coordinates of this point. What is B? Isn't B the point of intersection between N and this line here? See that? It's the point of intersection between the line N and this dotted line here. And the one thing that they're trying to tell us is, look, there's a perpendicular relationship here. And if there's a perpendicular relationship, perpendicularity always refers back to the slopes. So let's just see, can I get the slope of N? Well, I can, because once I know the equation of N, the slope of N, Mn, slope of N, is equal to minus the first number, minus 2 over 3, because it's minus a over b, which means that the slope of this line here, AB, is the negative inverse, which is 3 over 2. And if I have the slope of that line, and I have a point on it, which is A, and I know that A is minus 2, 1, because I've just taken care of that in the previous part of the question, then I can get the equation of AB. And if I have the equation of AB, and I also have the equation of N, then those simultaneous equations will give you the point of contact between the two lines, which is B that I'm looking for. So let's write down the equation of N. N is 2x plus 3y minus 51 is equal to 0. What is AB? Well, unfortunately, we don't know. So I fall back in coordinate geometry of the line. Point, slope, formula. Okay. Do I have a point on AB? Yes, I do. The point A, minus 2, 1. Do I have the slope of AB? Yes, I do. It's perpendicular to R, or to N, sorry. So therefore it's 3 over 2. And do I have the formula? Yeah, and it should be in your head. Okay, so now fill these two in here. So y minus 1 is equal to 3 over 2 times x minus 2 plus 2. And then get this form of the equation to match the form of the equation of N, so you can solve them as a pair of simultaneous equations. Clear the fraction. Multiply both sides by 2. 2y minus 2 equals 3x plus 6. Therefore, 3x minus 2y plus 6 plus 2 plus 8 is equal to 0. So there's equation number 1, There's equation number 2, and I'm going to solve these simultaneously to find out where do they meet, and they meet at B. So the solution of this will be the point I'm looking for. So let's write down n. N is 2x plus 3y. Now I'm going to write it equal to 51 because it's easier to shove the constants over on the right hand side when it comes to solving these things. So we take the minus 51 over to the right hand side. Same thing here. For AB, we're going to use 3x minus 2y equals minus 8. Okay? And we notice straight away that the y's have opposing signs. So therefore, all I've got to do is bring that to plus 6 and that to minus 6, and the y's will cancel. So I'm going to multiply the top line by 2, and I'm going to multiply the bottom line by 3. And when I do that, I get the following. 4x plus 6y equals 102. Bottom line, 9x minus 6y equals minus 24. Y's are gone. 13x is equal to 102 minus 24. Well, that'd be, if it was minus 20, 82, 78. And that means, hopefully, this 13 going to 78 6 times, 6 3s are 80, it does, 6 times. So there's x. Now, obviously, when you have x, you've got to work out the value of y. So you take this back to one of the first equations, let's take it to this one here, and work out what the corresponding value of y is. So now that x is 6, 3 times 6 minus 2y equals minus 8. 3 6s are 18. So that becomes minus 2y equals minus 8 minus 18 is minus 26. So y is 13. So what's the point of contact? The point of contact is the point 6, 13. And that's B that I was asked for. That's it. So pair simultaneous equations used there. And again, the whole focus of this question was brought back to the line. Okay, it's definitely a line question, but it's the coordinate of B is the intersection of the two lines, so therefore it's simultaneous equations. Okay, the next one. The two circles S and T are shown in the diagram. M is a tangent to S at A, highlight that, okay, and N is a tangent to T at B. Now we know these coordinates already, so we know what they are. So let's just go back and work out, what did we say B was a minute ago? 6, 13. So B is 6, 13. And what did we say A was? My memory is appalling. What did we say A was? A was the point minus 2, 1. Okay, so minus 2, 1. Now, what are we told? The ratio of the radius of S to the radius of T is 1:3. Okay, so the radius of S to the radius of T, the radius of S to the radius of T is 1:3. Now, if that's the case, if the radii have a ratio of 1:3, then the diameters will have the same. Watch. There's a diameter there, and there's another diameter here. The two diameters happen to cross the entire bridge between the line M and the line N. So if the radius of S to the radius of T is 1:3, then the diameter of S to the diameter of T will be exactly the same, which means we have a ratio of 1:3, and that is how I'm going to find the point between the two, because it says find the equation of S. Now, if I want to find the equation of S, the first thing I'm going to have to do is work out, first of all, its length, and then work out its radius. Work out its center and work out its radius. So find the equation of S, this one here. All right. The first thing I want to do is I want to work out, well, what's the point of contact between them? Because if I can work out the point of contact between the two, well, then I'll know how long, I can work out how long the radius of both of these are going to be. So here's what I do know. I've got a line running from minus 2, 1 all the way to 6, 13. Okay, so let's just take a look. So we're going from minus 2, 1. It's easier if you put these things out in a straight line. Minus 2, 1 to B, 6, 13. Okay. Now, what I do know is that these are in a ratio of 1:3. So you've got 1, 2, 1, 2, 3, 4, 5, 6. Yeah. So you'd have the radius here be 1:3. So that'd be the same as 1:3. So you could also say there's the center and there's the center. Now, if they want me to find the equation of S, I have to know its center and I have to know the length of its radius. So let's think about this for a moment. There are two radii here, and there are, what do we say, 3. So there'll be 6 of those here. So it's 2 is to 6 or 1 is to 3. That's going to give me this point. But I could also say that if that's 2 and there are 6 here, aren't there 8 bits altogether? So maybe if we do it that way, maybe if we focus on the radii themselves and say, well, let's put the center here. So you've got 1 of those there and 1 of those. Then you'd have the same thing here. There's 3 of them along this line and 3 of them along here. So that's 1 to 3, 1 to 3. See that? So that means that there are 1, 2, 6, 5 and 8. There are 8 pieces altogether. So there's 8 parts. Now, to get to this point here, you only have to go up 1/8. So therefore, what I want to do is I want to work out 1 is to 7. See that? That's what I want to do. I want to leave 7 parts over here, and I want to work out this one. So if I want to get to here, that's 1/8, and that's 7. So therefore, we can use the ratio this way, 8 parts. Okay, so there's the point I'm looking for. That is the center of S, all right? And I want to get the coordinates of that. And you'll do know that it's 1 of the 8s along the way. So there are 1/8 between A and the point I'm looking for, and there are 7/8 between the point I'm looking for and B. So all I've got to do now is work out what's happening with the X values. X goes from -2 to 6. That's an increase of 8, which is broken into 8 parts. So I divide it by 8 to find out how much one part is, and one part is +1. So therefore, straight away, I've got the X coordinate. To move from there to there, I'm going to add 1 onto the X value to go to -1. And next then, let's look at the Y's. What happens with the Y? It goes from 1 all the way to 13, which happens to be 12 units, which I'm going to divide across by 8, because don't forget there are 8 parts altogether between these. So you're going from 1 to 13, which is 12, and that gives you 6/4, or 3/2, or 1.5, 1.5. Okay, which means now that this point is 1.5 units up from this one here, which brings me to 2.5, and that is the center of the circle. So let's take a look at the circle. What have we got? The circle here, which we call S, will have a center at -1, 2.5, or 5/2, whatever you want to put it yourself, isn't it? What's that? 6/4, or 3/2. Yeah, 3/2. So 3/2, 1.5, which is 2. Yeah, that's fine. So it's 1.5 added on to 1, which is 2.5. That's it. So there's your center. And the radius, well, think about it. The radius happens to be 1 unit. Yeah. So the radius between these two, well, you can get the distance between them if you wish to do that as well. Let's get the distance between them, and we'll work out what the radius is. Because the radius is going to be the distance formula. So it'll be y2 minus y1. See that? y2 minus y1 to be squared, which is 1.5 to be squared, plus x2 minus x1 to be squared, which is 1 to be squared. So that comes out as the square root of 1.5, that's 2.25, that's 3.25. So just leave it as 3.25 for the moment. Leave r equals root 3.25, and we'll come back to it, because we know now that the radius is root 3.25. Okay, let's fill out the formula. If I know where the center is, and I know what its radius is, I use the formula that involves the center not being at 0, 0. So x minus h to be squared plus y minus k to be squared equals r squared. That gives me x minus minus 1, which is plus 1 to be squared, plus y minus, now that's going to be 2.5, or sorry, that's going to be, what is it, minus 2.5, or 5/2, whichever you want to do it yourself. 2.5 is fine. And that's equal to the radius squared. Now the radius is root 3.25, so 3.25 would be fine there. Okay. Now you could multiply it out if you want to, but that's perfectly fine. You can leave it as that equation, and that'll do. That's the equation of S. Okay, last question. A point X has coordinates -1, 6, and the slope of the line XC is 1/7. So where's XC? Okay, so the slope of this line here is 1/7. Find the equation of XC. Well, if I want to get the equation of XC, I need to know 3 things on XC: a point, the slope, and the formula. Okay, A point on xc. What is it? Point on xc is minus 1, 6. So you just go along xc to find a point you can use. The slope we're already told is 1 over 7. We're given that. So therefore the formula is y minus y1 equals m times x minus x1. And that's going to give me y minus 6 is equal to 1 over 7 times x minus minus 1, which is plus 1. Okay, so you're putting the point, you're putting the slope in there in order to get the formula. Now, you're going to multiply both sides by 7. So 7y minus 7 sixes, 42, is equal to x plus 1. And that gives me x minus 7y plus 43 is equal to 0. And why do I give it in that form? Because the question says to me ax plus by plus c is equal to 0. That must be in that form. Okay, check again. A, b and c are elements of what? Z. What's z? Integers. So therefore the values of a, b and c should be positive or negative whole numbers. A is 1, b is minus 7, c is 43. Bingo. Okay. C is the center of the circle S as shown. The line L, 3x plus 4y minus 21, is a tangent to S and passes through x as shown. Find the equation of one such circle S. Okay, so in this case, we're told what the radius is. We know the center is minus g minus f. So therefore, what I could do straight away is I could use the perpendicular distance formula between this point and this line here. Okay, knowing, as we do, that the radius is going to be, or the perpendicular distance is going to be 5 between them. So that's one way of doing it. I could also try and work out the equation of the radius. Now the problem with that is I don't have a point on the radius that I know. So therefore I'm going to stay way away from that for a moment. So what are we told? The radius is equal to 5. So the center is equal to minus g minus f. Okay, and we're also told that the radius, which is equal to the square root of g squared plus f squared minus c, is 5. Now I always put down the formula just in case we're going to use it later on. What do I know about the center? The center is on that line. I have it, but the center minus g minus f, because it's on this line, can be put into the equation of that line. So therefore the center gf is on what line? The line I've just discovered a moment ago, the line xc. And that's why they asked you to get the equation of xc, so that you could put minus g minus f in there, because my focus is to try and work out what those values are. So I need to develop two equations in g and in f. Okay, if you're asked for the center of the circle, because if it's asked me for the equation, I've got to work out the values of g and f. In order to work out the values of g and f, what do I need? I need two equations in g and f. That's how it works out. If you had three values, g, f and c, you need three equations in g, f and c. But here I need two. So the first thing I'm going to do is realize the center is on that line xc. So because it's on the line xc, I can put minus g minus f into the equation of xc, and the left hand side and the right hand side will be exactly the same. So therefore, put minus g in for x, minus g, minus f in here goes plus 7f, and that's plus 43 is equal to 0. Okay, so there's the first one. That's your first equation. Now, I could also get the perpendicular distance, as I said to you before, between this point and this line L, because we know the equation of L now. The equation of L is 3x plus 4y minus 21 is equal to 0. So once I know the equation, I can use the perpendicular distance formula now to work out the equation, to work out the distance 5 between these two. Set the perpendicular distance of 5 equal to the perpendicular distance between that point and that line. And what do I get? Well, let's work it out. Perpendicular distance, I'll write down the formula first, ax1 by1 plus c all over the square root of a squared plus b squared. Now, what point and what line? The point minus g minus f and the line here. So first of all, do I know what the perpendicular distance is? Yes, it's the length of the radius. So that gives me 5 is equal to, now let's put minus g minus f into this equation here. Minus g goes in there, that gives me minus 3g. Minus f goes in there, that gives me minus 4f. Minus 21 all over the square root of what? Of 9 a squared plus b squared, which is 16, which gives me minus 3g minus 4f minus 21 all over 5. But what is that equal to? That is equal to 5. Okay, that equation there is equal to 5. So if I take both of those, 5 equals minus 3g minus 4f minus 21 over 5. What does the question say? Find the equation of one such circle. So therefore all I've got to do now is get this into an equation, multiply both sides by 5. 25 equals minus 3g minus 4f minus 21. And what have I got? Minus 3g minus 4f minus 21 minus 25 is minus 46. And that's equal to 0. So you bring 25 over here. So minus 3g minus 4f minus 21 minus 25 is minus 46. So there's equation number 1 here in G and F, and there's equation number 2 in G and F. Why did I have to prepare 2 equations in G and F? Because the question said get the equation of the circle S. They've given me the radius, but they haven't given me the center. So the center is minus G minus F, which means there are 2 variables to be found. So you can use any tools that you have in your arsenal to get the 2 equations. Last thing I want to do now is simply solve the pair of simultaneous equations. So we get minus G plus 7F equals minus 43, and this one here is minus 3G minus 4F is equal to 46. Now again, you've got the signs of the F's are opposing, so you could cancel the F's as you want to. Might be easier just to multiply the top line by minus 3. That's what I'm going to do here. So that'll give me 3G minus 21F equals 3 3's are 9 and 3 4's are 12 plus 129. Underneath that, 3G minus 4F equals 46. The G's are gone. What does that leave me with? That leaves me with minus 25F is equal to 175. Therefore F, how many times is 25 going to 75? Well, 4 times into 100 and 7 times. So that's minus 7. And if you have F, you have to have a G. So what you do is you take the minus 7 back up to one of these equations here, and you put it in for F. So I'm going to get minus G plus 7 times minus 7 is minus 49 equals minus 43. Minus G equals minus 43 plus 49, which is 6. So therefore G is equal to minus 6. And what does it ask me to get? One of the equations. Now, first of all, do I know the center? Yes, I do. Now I know the center is minus G minus F. Well, F and G are minus 6 and minus 7. So that gives me the center of 6, 7. And a radius of 5. Now that I know the center and I know the radius, here's the equation of S. The equation of S is x plus 7, x minus 7 to be squared. What's x up here? I forgot again, 6. X minus 6 to be squared plus y minus 7 to be squared is equal to r squared, which is 25, because the radius is 5. So that's your center. So your center is equal to 6, 7, and your radius, as we said already, was equal to 5. That was given to me in the question. So you take those two in here to the second equation of the circle, because we know it's center, but it's not at 0, 0. So you use x minus h to be squared plus y minus k to be squared equals r squared, and you fill these values in, and there is one of the equations. Now, where would the other one come from? Well, that would come from back here, because we could have set minus 3g minus 4f minus 21 equal to minus 25, because don't forget, every time you have an absolute value, you've got 2 answers. So you could have set it equal to plus 25 or to minus 25. Both of those would have given you both circles, but you're only asked for 1. So if you're only asked for 1, take the positive value. Okay, now, hope that helps. If there's any question on that or anything you need clarified, get back to me. But my advice would be that you've worked through the questions first of all. Now you've seen the solutions. Now go back and try the questions again. Okay, and there is one more thing I want to do with you again, just as a quick revision, and that's how to build 3 equations in G, F and C, and then solve them algebraically to get the values of G, F and C and build the equation of a circle.